guys, Assalamu alaikum. Today we're going to start off with the chapter of capacitors. For capacitors, what you need to know is that it is a pair of parallel conductors separated by an insulator. So you take any two metal conductors and you put some insulator in between and it becomes a capacitor. Parallel conductors could be as simple as just two parallel metal plates, and insulator could be as simple as just simply air in between them. And then you use better insulators to ensure that no discharge occurs, but even air could be used as an insulator. Capacitors are very useful devices, and you might have seen those cylindrical capacitors in which the plates are cylindrical. But you might have seen those capacitors being used in air conditioners or fans, because generally when the performance of air conditioners or fans deteriorate, then you need to replace those capacitors. So you might have seen some electrician changing those capacitors. And as soon as those capacitors are being changed, then the efficiency increases drastically. So we're going to see that as well today, that why does that happen. So guys, first up, as I was saying, there's a pair of metal conductors separated by an insulator, and the purpose is just to store some amount of energy. And of course, you need to do some work because, you know, similar charges or same charges are being placed onto the same plate of capacitor. So if same charges are being placed, obviously you need to do some work to put repelling like charges onto the same plate. So work is being done to put all of these charges onto the same plate. And of course, you would require some sort of energy to do that. It could be as simple as connecting the parallel plates of capacitors to a battery. So when you connect it to a battery, then the positive terminal of the battery would push positive charges onto one plate of the capacitor, and on the other side, the negative end of the battery would push all the negative charges onto the other plates of the capacitor, and hence the charges will develop onto the two plates of the capacitor. Despite that, if we could see charges forming here, it is going to be incorrect if you say that capacitors store charges, because the fact is that it does not have any net charge. The amount of positive charge is equal to the amount of negative charge. So overall charge in the capacitor is zero. You could say that a charge is stored on each plate of capacitor. That's right. But if you say that charges are stored on the capacitor, that would be wrong. Instead, you should say that energy is stored on the capacitor, because obviously energy is required to put these charges over there. So obviously they store electrical potential energies. Now, guys, also one more thing that you need to identify right in the beginning, in case if any one of you might be thinking that probably this is something which could be used as battery or power source, then you need to identify that these charging times and discharging times are very short. They are, I mean, in the range of milliseconds and microseconds. And so this is definitely not an alternate to a battery. You might probably wonder in the beginning that, sir, what could possibly be a reason for having to store these charges for such little time? But the thing is that they only store energies for very little time. So in a very simple circuit, by the way, this is the symbol of capacitors. So you have two parallel lines being drawn, which would represent a capacitor. So in a very simple circuit, just to demonstrate the function of the capacitor, we could connect a two-way switch. On one side, you have a power source, and on the other side, you have a load. So when you would connect the switch to the power supply, the capacitor will get charged, which means positive charges will come on one side and negative charges will come on the other side. And it will charge to the voltage of the power supply. If the power supply is 2 volts, it will also charge to the voltage of 2 volts. So it's going to be an increasing voltage, and you would see that effect as the time increases, the voltage would increase, but it will stop to the voltage of the power supply. And then obviously no more charges would appear and no more voltage would increase. And then if you connect the two-way switch to the load, then what's going to happen? the voltage will now start decreasing because the charges will flow through the load. And as the charges will flow through the load, then these charges will be utilized, the energy of these charges will be utilized, and the lamp is going to glow for a very short duration of time, which would be equal to the charging time, that's equal to the discharging time. And the lamp is going to glow brightly in the beginning, but as you see that the charges will keep on flowing through the lamp, so as the charges will flow through the lamp, so what's going to happen because of that? That the voltage will start decreasing, and as the voltage will start decreasing, so hence the lamp will go dimmer, 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 and eventually it will go out. So uh, it will be a slow process of charging. It will be a short duration time in which the capacitor will get charged, and also a short duration of time in which the capacitor will get discharged. And because of that, the lamp will glow brightly in the beginning, but it will keep on going dimmer, dimmer, and eventually it will die out. And that's going to happen in the process of charging and discharging, which can be demonstrated by that circuit. Then with each capacitor, we associate a certain physical property that's called capacitance of a capacitor. And as the name indicates, capacitance is like the ability of how many charges can be put up on each plate of the capacitor, but with respect to voltage. So how much charge is stored per unit voltage is called the capacitance. So it could be coulombs per volt, but there's a derived unit for that, which is farad. So capacitance is the ratio of charge to voltage, or also the ratio of the change in charge to the change in voltage. And that will give you the capacitance of a capacitor. There are different applications. I mean, right in the beginning, I was saying that if it stores or if it gets charges for such a short duration of time, then what could be a purpose of that? There are many different applications. I was just in the beginning telling you that capacitors are used in fans and air conditioners, and it also is used in many appliances which have motors in them. So, and as I said, I mean, if you would try and find out that in many situations the efficiency of the fan becomes very bad. I mean, you could see that the fan is rotating very, very slow. And a simple solution to that is, in most of the cases, that you just get the capacitor replaced. So you have a new capacitor and the fan starts working normally. So what is the function of a capacitor inside that circuit? And same thing, by the way, you have a bigger size capacitor for an air conditioner, but again, the function is pretty much the same. So guys, what happens in these situations is that, first of all, you need to rectify the current. By the way, this is something we're going to be discussing in a lot more detail in another chapter that's called alternating current. But somehow you have these circuits which would require a DC current, a current that's flowing in one direction, because you want to make motor rotate in one direction. So you want the current to be coming in the same direction as well. So you use diode as a rectifier here. I mean, you use the diode as a rectifier. So what diode is going to do is that, because it's an alternating current, so it only allows current to flow in one direction. And if the current tends to flow in the opposite direction, it will stop that current. So when the diode is going to allow the current to flow, the current would be used to charge the capacitor, and the current would be also used to run the load. So during that part of the cycle, not only the load functions normally because of the current coming from the supply, but also that current from the supply is used to charge the capacitor. But then when since there's an alternating current, when the current tends to flow in the opposite direction, that current would be stopped. And that creates a bit of a pause in current flow in the external load, and that will cause the load not to function at a better speed or a better efficiency. Putting a capacitor in parallel would do what? That, when the current was flowing in the positive direction, the capacitor got charged. The same charges, when the supply stops providing charges, due to the diode, the capacitor would provide or supply charges to the load, and hence that will run. But that happens for a very short duration of time. As I said, the capacitors are devices which only function for a short duration of time. So it's just like for a very short duration of time, the current stops flowing, but during that period, the capacitors will start providing energy or charges, and the load would function to a certain higher speed or near to a normal speed. And by the time the voltage across the capacitor would start decreasing, the diode would become forward biased again, and the current from the supply would again arrive and run the load. As I said, I mean, this is something we're going to be discussing in a lot more detail later on, but this is how the original supply of the current looks like. And when it's going to be rectified with the help of the diode, this is how it's going to become. So these flatter portions will make the device not work normally, and hence it will work at a lower efficiency. What capacitor does is that sort of maintains that voltage, and hence it doesn't allow the voltage to drop down too quickly, and hence the device would start working at a better speed. That's one function of the capacitor, guys. The other function of the capacitor is that it is used in tuning circuits. The radio sets, which are used to tune into a certain frequency, if you want to listen to a particular radio station, let's say FM 100 or FM 101. So you need to tune the frequency of your circuit to the frequency of the arriving signal. You want to listen to FM 100, you would want the receiving radio to be working at 100 megahertz frequency as well. So you need to tune it, and the alternating current frequency in circuits depends upon their capacitance. So if you connect a capacitor in those circuits, the capacitance would affect the frequency. There's a lot more detail to that. You can research that, but in our circuit, we are not supposed to go into that detail. We just need to know that the capacitance affects the frequency. So if I change the capacitance of the circuit, the frequency would get altered, and I can tune it to the frequency of the arriving signal. So in old days, you might have seen those big radio sets, which are big control knobs. So when you were rotating the control knobs, the plates were sliding over each other like this. So that changed the area of contact of two capacitors, and that would affect the natural frequency due to change capacitance, and hence they could tune into different frequencies. Now we have digital circuits, so we just, and by the way, I mean, we already know, we talked about that, our mobile phones are also radio frequency transmitter and receivers. So when you're making a phone call, so there's an electronic circuit which would affect the capacitance of the circuit inside, and hence it can obviously acquire the frequency that it needs to achieve. The last application that I want to tell you is about achieving a very high voltage out of a low voltage supply. So what you could do is that you could connect the power supply. You could connect the power supply to a couple of capacitors. In this case, we have 3 capacitors in parallel to the power supply. So guys, what's going to happen is that, let's say I have a 2-volt power supply. So if I have a 2-volt power supply, that will charge each of these capacitors up to 2 volts. And once it will charge each of these capacitors up to 2 volts, then you can connect, you have another circuit combination over here, which is connecting these capacitors in series to each other. And if you connect it to a lamp, so what's going to happen? The lamp will get 6 volts altogether. It won't run for a longer duration of time, but it can get a higher voltage. So you can use a lamp that has a bigger working voltage with these capacitors connected this way. One application I could tell you that's, again, more of an obsolete technology, but if you go back like probably 10 years, and you'd find out that the cameras used to have filament bulbs. Now they have LEDs, which don't require a lot of voltage, and they do produce a lot of brightness, but the filament lamp needed to be requiring a lot of voltage. So what you could do is, and of course, if you would provide that amount of batteries onto the camera, then the camera would become too heavy to carry. So what you could do is that you could have this kind of a circuit where a small battery could charge up multiple capacitors, and those multiple capacitors, because while taking a picture, you just need an instantaneous burst of light, and that could be provided by this particular socket. So once you would click a camera, this socket would go on, and as the socket would go on, the lamp is going to glow brightly for an instant. It could take a picture, and then again it will start. The capacitor will start getting charged with the help of the power supply. These circuits would have batteries running out very quickly. But you could replace these batteries quickly, but that gives you an advantage of not carrying while taking a picture, not carrying a very high load of batteries with you, because with small batteries, you're still able to run a very high voltage lamp.